All right, so just pick up where we left off. All I want you to do, you don't have to graph. Don't graph. Just find the equation. Of the line that passes through -4, -3, and 1, 5. So go ahead, do that. I'll give you like a couple minutes. It's gonna. I would imagine it's gonna take you a couple minutes. Okay. Did anybody get an answer, or do you still need another minute or two? I said I think we might need another minute or two because this just takes time to do. Okay, are we ready? Who got an answer? What is that equation of the line?
I'll take a shot.
Go for it.
I got y equals negative 8/5 plus 4.
Y equals negative 8 over 5 plus 4.
Yes.
So there's no x.
Or plus 4x, my bad.
So negative 8 over 5 plus 4x.
Yeah.
So another way to write that would just be like this then. Okay. All right, let's see if you're right. So step 1. Do we know the slope or do we have to calculate it? Yeah, we're going to calculate it. So m is going to equal, and I'll make this 0.1 and this 0.2. So let me just set up real quick. So it looks like I'm going to have 5 minus negative 3 divided by 1 minus negative 4. So that's going to be 5 plus 3 over 1 plus 4 equals, I came up with 8 over 5. Is my math incorrect? Or does my math look pretty good?
I got 8 over 5.
Okay, all right. So, Brendan, our slopes are a little bit different right now. Okay? So now step 2.
I know what I did wrong. My bad. It is positive 8 over 5.
Okay. So now for step 2, what we need to do is pick a point and run with it. In other words, we're going to substitute in for x1, y1. It doesn't matter what point you pick. So what I'm going to do is I'm just going to write the equation first with my slope. And now I'm going to pick my point. Sorry, there we go. Little Ernie or Galileo hair on my computer. So let's see here. What point do I want? I'm going to pick point 2 because there's less negative signs. So I get y minus 5 equals 8 over 5 times x minus 1. Now I need to solve for y. That's step 3. So just give me a sec. I'm just rewriting it. So now I'm going to distribute. That gives me 8 over 5x minus 8 over 5. And then the last thing I'm going to do is add 5 to both sides to give me y equals 8 over 5x. Now I got to go ahead and add fractions, which I know we hate that, but we got to deal with it. So it's going to be negative 8 over 5 plus 5 over 1. I need a common denominator of 5. So I multiply the second fraction by 5 over 5. That's going to give me negative 8 plus 25 over 5. So I get negative 8 plus 25, which is going to be positive 17 over 5. Did anybody else get exactly what I have on the board? Or did I get something completely wrong? Because I can make a mistake. I am not perfect.
I got that.
All right, I'm feeling good when I hear confirmation. Anybody else?
I did.
Megan H., you got it as well. Thank you. All right, so are there any questions? Okay, here comes the fun part. I think I'm just going to pick you up and throw you in the deep end of the swimming pool. I want to see if you can swim. Okay? Don't do it, Galileo. All right, there's your question. Don't step on the keyboard. Come on. There you go. So I want you to find an equation of the line that is parallel to the line y equals 3x plus 1, and it passes through the point 4, 2. Now, you have all the tools necessary to figure out this problem on your own. You do. You just got to think about what I'm asking and how can you get to your goal. So I'm going to let you try to figure this out. Okay, are we ready? Hallie, what did you get?
I got y equals 3x minus 10.
Can you explain to us how you got that? Because I don't know if you're correct. I didn't do the problem, but just walk us through your thought process. And what I'm going to do is I'll write it down, but just please be descriptive.
Okay, well, it's asking to find a line that's parallel, so I knew that the slope would be the same.
Okay, hold on one sec, because that is the key to this entire problem. All right? They're asking us to find, They're asking us to find an equation of the line parallel to another line. And we know, by definition, that's a horrible looking F. By definition, parallel lines have the same slope and two different Y-intercepts. So far, if I'm looking at Haley's line, 3x, the slopes are the same. Did I say Haley? I meant Hallie. Sorry. It just hit me. So if I look at Hallie's example, or answer, we got 3x and 3x. So the slopes are same. Awesome. Different Y-intercepts. 0, 1 for the first, and then the line that Hallie calculated, 0, negative 10. So I'm looking at your answer, and I'm like, this is awesome. Like, and you should look back on your answer and go, hey, it makes sense. Now, let's make sure it's correct. So we know when we find the equation of the line, step one, you got to find your slope. It's either going to be given to you or you're going to calculate it. And Hallie? You said slope equaled 3. I love it. So, what's our second step?
So I used the point slope form to find the new y-intercept.
Okay, and what point did you use?
4 comma 2.
4 comma 2, because that was given. So, y minus 2 equals 3 times the quantity, x minus 4. And now I'm assuming you solved for y, am I correct?
Yes.
So, y minus 2 equals 3x minus 12. Now I add 2 to both sides. Y equals 3x minus 10. Now, before I let you go, what would be a really fast, easy way to check yourself to make sure you're correct?
Desmos.
Yeah, Desmos. So let's go ahead. I'm going to drag this over. Okay, and let's look here. The first equation, y equals 3x plus 1. The second equation, which is the line parallel, y equals 3x minus 10. And boy, does that look beautiful. Look at that. There's the y-intercept for the first. Here's the y-intercept for the second. And they totally look parallel to me. So, Hallie, excellent job. I couldn't have done it better myself. If we were in class right now, I would have just had you go up to the board and teach it to us. That's what I would have done. Teaching's fun, especially when somebody else does it. So, let me zoom out. Are there any questions? Because I'm going to be honest. This is the hardest type of problem that we're going to be looking at. Next to the application problems, which we're going to be doing in a little bit. So I need to know, do we have any questions?
Could we do another example?
I would love to do another example, Mara. So, do you want one that's parallel or would you like one that's perpendicular?
Perpendicular, please.
Okay, watch this. Are you watching the screen right now?
Yes.
Watch this. There you go. Same exact problem, just find one that's perpendicular now. So the directions are the same. Find an equation of the line that is perpendicular to y equals 3x plus 1 and passes through the point 4 comma 2. And here's your hint. You got to know the definition of perpendicular lines. If you know that, everything else is a downhill slope after this. Pun intended. Right, Amy? Okay, how we doing?
I think I solved it.
Yeah? What'd you get?
So I got y plus 10 over 3 equals to x.
I'm going to have to disagree with that. You didn't have the correct slope. Anybody else get a different answer? How many of us are stumped and you just are thinking, man, I just want him to go over it?
Me.
All right, Craig, you ready? Here we go. We want to find the equation of a line that is perpendicular. What do perpendicular slopes look like?
Opposite reciprocal.
Opposite reciprocals, very good. So, if the slope for our first line is 3, then what does the slope for our second line have to be? Well, it has to be the opposite reciprocal. So the opposite of a positive is a negative, and the reciprocal of 3 over 1 is 1 over 3. So there's our step 1. M equals negative 1/3. Now for step 2, I want this perpendicular line to be, or I want this to be not only perpendicular to y equals 3x plus 1, but I also want it to pass through the point 4, 2. So y minus y1 equals negative 1/3 x minus x1. I need to make my substitution, so it's going to be y minus 2 equals negative 1/3 times x minus 4. So from here, step 3, I'm going to rewrite the problem, and then I'm going to solve for y. So let's go ahead and distribute the negative 1/3 first. Y minus 2 equals negative 1/3 x plus 4 over 3. And now I have to add 2 to that. So plus 2 and plus 2. So y is going to equal negative 1/3 x. But give me a second. Let me add some fractions. So I'm going to go off to the right. 4 over 3 plus 2 over 1. I need a common denominator of 3. So I multiply the second fraction by 3 over 3. That is going to give me 4 over 3 plus 6 over 3 for a total of 10 over 3. So I know that if I were to graph this line that I have right here, not only does it have to intersect, but it has to make a 90-degree angle. All right? So let's see if I'm right. So go over to back to Desmos here. Let me get rid of my parallel line. And let's type in y equals, what was it, negative 1/3? X plus 10 over 3. Well, I don't know about you, but that looks like a right angle to me, a 90-degree angle. Would you agree? Okay. Now, I'm going to go back to our work because I want to just talk about this for a little bit. There is a reason why I wrote both of these side by side. Normally, I would just scroll up, and do the problem over again. But there's a reason why I wrote these side by side. Because the point I'm trying to drive home here is this. Did my process change? Did my step 1, step 2, and step 3, did they change? Not at all. The key to both of these problems dealt with one central concept. And I'll give you a hint. It starts with the letter S and rhymes with lope. Anyone? Slope. Step 1 in both situations was still find the slope. It's just now I'm giving you a little bit of information. I'm saying make it parallel or make it perpendicular. But regardless of the question, you have to find slope for both of them. That's how important slope is. Okay? So if you really think about it, next week on Wednesday, you're going to have a test. And if you think about it, how many different things am I really testing you on? So let's think about this. Ready? Section 1 dealt with just the rectangular coordinate system, plotting points, determining if something is a solution. How many questions do you think on a test I'd put with something like that? Just take a guess. 5? Dawn, I wish. Maybe 2 questions. Because I know in order to do everything else, you got to know how to plot a point. All right, so 1 or 2 questions on that. Section 2 dealt with graphing. You're going to have a lot of questions with graphing. All right, because you're going to know how to graph. I'd say 2 or 3. Probably 3. But you never know. I may say, hey, graph these 2 lines and show me that they're parallel. So you got to know how to do section 2. Section 3 dealt with intercepts. Section 4 dealt with understanding slope. Knowing that there's 4 types: positive, negative, a slope equal to 0, which is a horizontal line, and then a slope that is undefined, which is a vertical line. Section 5 and 6 both dealt with slope-intercept form and finding equations of lines. If you were to bet money out of section 1, 2, 3, 4, and 5, what 2 sections do you think I'm going to test you on the most? Here, I'll put them over here so you can see them again. Here they are right here. Out of section 1, 2, 3, 4, 5, and 6, what 2 do you think I'm going to really be testing you on?
4 and 5.
Not 4 and 5.
5 and 6.
5 and 6. Because in order for you to do 4 and 5 or 5 and 6, you got to do 1 through 4. You got to be able to do 1 through 4. Okay? Now, if we really think about it, let me go back to our notes. In sections 5 and 6, how many steps did you need to know how to do? The answer's on the board. How many steps? 3. Know how to find your slope. Know how to substitute into point slope equation. And then know how to solve for y. There may be a 4th step, which is graph it. Does that make sense, everyone? All right? I'm not saying sections 1 through 4 are not important. They are. What I'm saying is 5, 6, and 7, which we're going to do here in a little bit, that's where the money is. So if your exam was, 10 questions, 7 of them would just be on sections 5 and 6. That's 70% of your test. The other 3 questions, one of them would be plot a point. Another one may be something like, interpret the slope. And then the last one would be graph this linear inequality, which we'll do in a little bit. Okay? Are there any questions? I'm not trying to scare anyone here. I'm just trying to prepare us. No questions. All right, then. So let's go over graphing linear inequalities. Okay? And this is the last section of the chapter. All right. Did I hit record earlier or not? Yeah, I did. So here's what I'm going to do.